Alright, good afternoon everybody. So welcome, welcome to the class. Let us begin from where we ended the last class. Okay. So we actually talked about the common materials for the membranes, and we discussed, how hydrophilic and hydrophobic nature actually affects the membrane's performances, and we discussed that uh, the more hydrophilic membranes are better suited because there will be higher flux possible for through the membrane, and as we understand, higher flux possible means you require lower amount of membrane area per meter cube of water that you uh, filter through the membrane. So, but most of the times hydrophilic membranes are also liable to bacterial attack, and also they can be very easily oxidized. So we need some kind of membrane which has got some hydrophobic nature as well as can be resistant to oxidation. So for this, we also have this type of membrane, a polysulfone, polyether sulfone membranes, where there is a hydrophobic group, like phenol group, which is hydrophobic, and we also have sulfonic acid groups. These are called sulfonic acid groups. And sulfonic acid groups are basically hydrophilic in nature. So you have a suitable amount of hydrophilic and hydrophobic mixture. So these membranes are good, but they are again very good for resistance to biological attack, and also chemical tolerance is good. But again, they are not so as great as like PVDF membranes, which are polyvinyl iodide fluoride membranes, and as because we have fluoride in part of the polymer network, it has got some hydrophilicity as well as hydrophobic nature is there because it's an aliphatic chain. So here adhesive cleaning and disinfection is possible. Now we also talk about polypropylene membranes, which are essentially hydrophobic membranes, and they have excellent removal capacity for particles and maybe macromolecules, but they are not so much. Uh, they offer high resistance for the flow of water because they are hydrophobic in nature. Okay. Now we are talked about ceramic membranes, which are basically cast type of membrane, and we do not have much flexibility, and only tubular nature of configuration is possible. Now we will discuss about the how the ultrafiltration membranes are actually configured in in the practice. Now, before we get into this, let me also talk about the microfiltration membrane, how they are actually arranged and how they are used in the real life sense. So this is, I just had this slide from, place this slide right now over here so that you can think about the continuity. So this is about microfiltration membranes. Don't kind of you know mistake it with ultrafiltration membranes. So microfiltration membranes are basically for removal of particles. So particles are removed from these membranes, and as you can see, we can have you know initially this is the water that we need to feed into the system. So you have this pre-filter. We talked about the pre-filter. If you can remember that, some coarse and finer pre-filter, what are the effects on our filtration volume versus pressure requirement. So there is a pre-filter provided here, and then we take it into the beverage system.